Right, I apologize. I inadvertently stopped that last video, so we're going to try this again. So we were at the point where we had just taken the derivative of the r of t equation, and we're about to find the magnitude in general of r prime of t. So not with the evaluation of the t equal 1, but in general. So in general now I'm going to have the square root of 1 squared, which would be 1, plus 2 squared, which would be 4, plus 2t squared, which would be 4t squared. So this gives me a square root of 5 plus 4t squared. Alright, at this point that allows me to find t of t. So that's each of the t, 2t, and t squared derivatives divided by the magnitude. So I end up getting 1 over the square root of 5 plus 4t squared. And then I have 2 over the same quantity, square root of 5 plus 4t squared. And then a third one, which would be 2t over the square root of 5 plus 4t squared. And now that we have this vector, we can actually evaluate t of 1. We didn't need to do this t of t in order to evaluate t of 1. We could have done it directly by using the 1 involved in each of the other two. But to find my normal vector n of 1, we need the t of t to be written in general form in order to be able to take its derivative. Alright, so on t of 1, I actually get 1 over, and then 5 plus 4, because the t squared becomes 1. So this would be the square root of 9, which is 3. And then I've got 2/3. And on the last one, when I plug in the number 1, I get another 2 in the numerator, and I get still 3 in the denominator. So this is the vector t of 1 actually, t of t when t equal 1. Alright, so the next thing we're going to do is we're going to find the derivative of our t of t. So that is, we're going to find t prime of t. Now, what we have here is, one way you could do it anyway is just playing a chain rule as though the exponent were a -2. And that works pretty well. Let me just jot down a little bit of the details on that just to remind you, and then I'll erase them so that you're sort of in the effort of saving a little bit of space. But this is, in essence, 5 plus 4t squared to the -1/2 already. So if I bring my -1/2 down, I write my 5 times plus 4t squared to the new power, which would be -3/2. And then I end up having the derivative of the inside, which would be 8t, which would simplify with this 2 to give me a 4t, and negative, of course, as well on top. And I can move the power of 3/2 to the bottom. So the first one and the second one are almost exactly the same like this. The first time I'm going to get a 4 here. So -4t over 5 plus 4t squared to the to the 3/2 because we moved it down. And your second thing is exactly the same, it's just going to be double this, so it's going to be 8t, -8t, over 5 plus 4t squared. To the 3/2. And last but not least is my third component, which definitely the more complicated one because I've got two variables. I've got the variable in two locations anyway. I've got the variable in the numerator and I've got a variable in the denominator. So on this one we actually have to work a little bit harder to get these pieces. Now some of it's the same, but just not all of it. Now in general, when we start out this problem, this would either be a chain rule or a quotient rule, depending on how you wanted to, a product rule or a quotient rule, depending on how you wanted to proceed with it. What we're going to do here is we're going to do it as a quotient rule. So I'm going to have the denominator times the derivative of the numerator plus the numerator times the derivative of the denominator. We've already worked through this on other problems, so I'm not going to belabor the point too much. Alright, so there's the 1/2. What am I missing? The 8t. That's a perfectly fine location for it, simply because we're doing multiplication here. And this is all over the denominator squared, which would then give me 5 plus 4t squared. Okay, now to find the last pieces of information, we can actually evaluate this t prime of t at the value of 1. So putting in the number 1, I get a -4 on top. I get the 9 on the bottom, which I square root to be 3. And then I cube it to get 27. So this is going to give me -4 over 27. In the middle, it's still going to be over the same 27, but we're going to have -8. Right, and then the last one is going to give you 3 times 2 plus 8t squared. So that's just going to be 8. And that's going to be over 9 all over and 9 here as well. Okay, and this last piece also works out to being 10 over 27 if we were to reduce it. So another over 27. Alright, then if we evaluate this, find the magnitude, we actually get the square root of 20 over 81, which would be 2 square roots of 5 over 9. So that's our magnitude of t prime of 1, and now we have to find n of 1. So the way that we find n of 1 is, of course, doing t prime of 1 over the magnitude of t prime of 1. Alright, so t prime of 1 was my -4 over 27. And I'm supposed to divide by t prime of 1, but I think what I'm going to do instead is I'll multiply by the reciprocal. So this would be times the 9 over 2 square root of 5. Same kind of things happening right here. I've got -8 over 27. This is times, again, the 9 over 2 square root of 5. And then I've got 10 over 27 times the 9 over 2 square root of 5. Alright. If we work a little bit of simplifying on this, we end up getting what we have, -2 over 3 square root of 5, -4 over 3 square root of 5, and square root of 5 over 3. Now, if you want to rationalize those, that's great. If you don't rationalize them, it's okay. Your book will leave you answers just like this in simplest form. All right, so we still haven't found everything we want, though we've found all the details that we need to get where we want. I need to find the binomial vector. So the binomial vector says that I should be able to take the I, the j, the k, and I should be able to use the values that we found above. So this is 1/3, 2/3, 2/3, and -2 over 3 square root 5, -4 over 3 square root 5, and square root of 5 over 3. Alright, so we're going to do determinant expansion on this. I'm going to have 2 square root 5 over 9 plus 8 over 9 square root 5 times my I minus square root 5 over 9 plus 4 over 9 square root 5 j. And the last piece is negative 4 over 9 square root 5 plus 4 over 9 square root 5, quite possibly my favorite answer of the day, because this adds, of course, to 0. Okay. All right, so if we simplify the pieces that we have, we find out that we get 18 over 9, that's like 2 over square root 5, times I, minus 1, it would be 9 over 9 square root of 5, so this is minus 1 over square root of 5, j. And that is our binormal vector, b of t. Now let me just sort of prep the environment for what we're going to do on this last problem. The idea on this last problem is that for each point on a curve, the plane that passes through that point and is determined by n of t and b of t is called a normal plane. And for each point on the curve, the plane determined by this is called the oscillating plane. So we're looking at this oscillating plane. For a given value of t, if the curvature k is at a point p corresponding to t0 is non-zero, then the circle of radius rho equals 1 over to k lies completely in the oscillating plane, whose center is the distance 1 over k from p along the curvature, along the normal n of t, and it's called an oscillating circle or oscillating curvature, circle of curvature. The radius is called the radius of curvature, and the center is called the center of curvature. So next time you're going to have a little bit of homework from this section. Let me give you an example of one that we're going to do here. And the directions talk about this oscillating plane, so it wants us to find the oscillating circle at the given point. Oops. All right, so R of t is going to be one that we've actually already seen today earlier. We're going to work from what we already know. And when you are doing this in your homework, the same thing's going to happen. I'm going to choose, or I already have chosen, the problems, and they will have another value that you've messed with and played with them to find other things before. Okay, so this is my vector. It's exactly like I found on or was given on example number 1. And we're asked to find some information about this, the oscillating circle. So to start with, from example 1, we know what do we know? Well, we know that t of 0 is 0, 1, and we also had found out in that problem set that n of 0 is negative 1, 0. So then my curvature, which is the magnitude of t, prime of t, over the magnitude of r prime of t. So our k would be the number 0, 1, which has length 1. Sorry, trying to get this transcribed down right. Okay, so on the top, the magnitude of t prime of t is 2/3. And then the magnitude of r prime is actually 3. So we get that the curvature is 2/9. So the radius is at a distance that's 1/2 the 2/9, or 9/2, from the center of the circle. So the center is at P, which is r of 0, which when evaluated is actually 2, 0. And it's supposed to be in the direction of our normal vector, -1. Okay. -1, 0. So the center is at, so it's this component -1, and I'm going to subtract off 9/2, which is going to give me -5/2, and the 0 didn't change this one at all. And the equation of the circle is x plus 5/2 squared plus y squared equals 81/4. All right, so the homework from this section is on page 797, and it's kind of a few different topics as we did in our homework, or in our lesson part. So we've got 2, 5, 7, 10, and 12, and then 22 and 23.